can still don't hear Ryan. Is it normal?
Can you hear me now?
Yep.
Okay.
Welcome to my OpenXR masterclass.
Next slide.
Plan for the talk today is to spend a few moments introducing myself, introducing OpenXR, and looking at OpenXR as a standard in context, what it is and isn't. Then we'll take a deep dive into OpenXR application structure and API usage. And we should have time for question and answer at the end. My name is Ryan PAVLIC. I've been working in the VR realm since around 2009. I've been involved with the OpenXR working group since the first official meeting in 2017. I was elected specification editor for the OpenXR working group in 2019. My job currently is as a principal software engineer at COLLABORA, where I work on the XR team and work as a developer on Monado, which is our OpenXR runtime.
Next slide.
So what is OpenXR? Well, OpenXR is a royalty-free open standard that provides high-performance access to augmented reality and virtual reality, so AR and VR, or XR collectively, platforms and devices. The provisional release 0.90 was released at the Game Developers Conference 2019 in order to publicly show progress and seek feedback. We released version 1.0 of the specification at SIGGRAPH in 2019. The 1.0 release defines an interface between engine or application and a runtime, and the required behavior of a runtime, not control the interaction of a runtime and underlying devices. I'll get to that in a moment. Like many KHRONOS standards, conformance tests are a part of the package. Runtime conformance tests and adapter program are forthcoming. That's one of the main focuses of the working group at this time.
And next slide.
As I mentioned, the 1.0 specification includes the interface to the application with a compatibility promise that comes with 1.0. So now is the time to start building applications on top of OpenXR. 1.0.x patch releases are minor changes that fix spec bugs or add extensions. These are typically released on Fridays. My general rule of thumb is that if there's a specification change or extension changes that are in the KHRONOS private GitLab instance for a given week, I will typically cut a patch release for that week. So the time between patch releases can be variable, but I work to get whatever the working group has put together out as quickly as possible. Now, if you go to the KHRONOS website or look around at some articles, you might see mention of a different diagram that has a device layer, which would allow a single runtime to connect to multiple XR devices. The diagram at the right is a more accurate description of the current 1.0 ecosystem. There's no standardized interface between runtimes and XR devices. There's no device plugins, but runtimes may support one device or more than one. And importantly, the interface between an application and the runtime is standardized, so you can use your applications across multiple runtimes and thus multiple devices. There's no public estimated time to have the device layer as in the statement of work and the marketing materials ready. And earlier, the main focus of the working group at this point is finishing up the conformance tests. We're also very interested in promoting uptake and adoption of the new standard.
It appears we can't hear you anymore.
Yeah, one moment. So what is OpenXR in context? It's a KHRONOS API, which means that it comes from the same organization that maintains OpenGL and Vulkan. Can you hear me okay still?
Yes.
Okay, I just heard someone else talking, so I didn't know if there was a problem. So KHRONOS is a nonprofit industry consortium that works to produce open royalty-free standards. Like many KHRONOS standards, in OpenXR, extensions are a key part of the design. They're a way for vendors to provide additional vendor-specific functionality without breaking the compatibility with other devices. As with other KHRONOS API standards, conforming runtime that passes the conformance test and completes the adopter program receives patent and trademark licenses per the IP framework. And OpenXR, like other KHRONOS standards, is royalty-free. I'm not a lawyer, but the IP framework is a very important part of the process. It's essentially what makes KHRONOS such a special place where these tech leaders can come together and talk freely and work on compatibility and cross-vendor standards. OpenXR specifically in its conventions in API, as well as its specification style, is strongly influenced by Vulkan. We have an almost completely shared tool chain for generating the specification documents and the headers. We have pretty similar development and release practices. And just like Vulkan, we have support for API layers. API layers are a standardized way to hook one or more calls in the API in a way that is supported reasonably through the loader. Go to the next slide. So I mentioned that OpenXR shares similarities with Vulkan, but there are some differences. Vulkan is a low-level, very high-performance rendering and compute API. OpenXR, as focused on applications for VR and AR, is rendering API neutral. All graphics API is supported through extensions. So you have to use at least one extension to render anything in OpenXR. There's support not only for Vulkan and OpenGL, but also for the Direct3D family of graphics APIs. So it's not limited just to KHRONOS standards there. Additionally, OpenXR is a lower frequency API, which influenced some of our design choices. By that, I mean you're not going to be executing hundreds of OpenXR calls every frame. There's not a concern about completely minimizing every bit of per call overhead. In Vulkan, there are valid usage constraints on the API calls, and there's a validation layer, which you're supposed to use during development. And the validation layer will do checks to make sure that you're meeting the valid usage requirements. And then at runtime in production, you don't use the validation layer. So the runtime or the driver in that case, just assumes that you are calling everything correctly. OpenXR, because it's lower frequency, we have fewer calls, doesn't need to be quite so draconian. There is a validation layer and it can provide useful information, but unlike Vulkan, most OpenXR calls require the runtime to check for most valid usage errors and return a error code accordingly. So there is much less in the realm of undefined behavior in OpenXR. There is some risk of undefined behavior simply because it's a C API, but that can be reduced further by using a language projection or a wrapper. I'm aware of, there's a C++ one that is developed by me and a community member, and there's also one for Rust developed by a community member, and both these reduce the risk of undefined behavior. OpenXR is also a much smaller spec than Vulkan. It's only about 300 pages in the PDF form. It does not take long to load. And we also have the advantage that we were able to ask the Vulkan team what lessons they've learned, what things they'd wish they'd done different. One change that flows out of that is that our loader, which is responsible for finding the runtimes and attaching API layers, etc. Our loader ships with applications. It doesn't ship with the system or the driver on Windows. So you won't have any drivers overwriting each other's copies of the loader. And the application will get a version of the loader that does for sure what it needs. It's still a system-wide install on Linux, at least tentatively as of right now, because Linux distributions tend to have a distribution-specific method for avoiding conflicts between packages and resolving those. You can go to the next slide. So as of this moment, so that is April 22nd, 2020, this is the availability of OpenXR runtimes. Microsoft has their OpenXR runtime for Windows MR HMDs, as well as the HoloLens 2 integrated AR device available. There's a shortcut link there. I'll try to get slides posted somewhere so that you can click these links, because I have links all over the presentation. So their runtime is available. You can search for OpenXR on the Microsoft Store. One interesting bit about their runtime is that it also works with a device simulator, so you don't need their VR hardware to try it out. You can go into developer mode in the mixed reality portal and enable simulation there and use that. Additionally, Oculus, that link there is to a press release on desktop. So this is Rift and Rift S. They have a runtime that they've been developing in prototype form on the public test channel. The SDK for that will be officially rolled out soon. This was in one of their press releases from when they planned GDC. The mobile runtime, so this is primarily for the Oculus Quest. They do have their OpenXR mobile SDK 1.0.6 available. If you're using Linux on one of many different devices, you can use Monado. This is an open source project founded by COLLABORA, my employer. This is something I work on quite a lot. It supports a wide range of devices and is a good experimentation platform, and should be portable to other operating systems if community members are interested and get involved. Now note that these are all technically previews because the conformance tests are not yet finished and not published, and the adapter program is not fully rolled out. So these are all technically preview implementations of OpenXR in various states of completion. But they are sufficient to start developing and testing applications now. Fine. So here's the general structure of an OpenXR application. When you get started, the first step is to get an instance. You then find out where and how to run. This involves the system ID atom, as well as the view configuration type enum. Next step is to set up your interaction and input handles, create action sets, actions, and suggest bindings. OpenXR uses an action system instead of a more closely hardware coupled system to handle interaction. Don't worry, we'll talk about that. Prepare your immersive experience. These are the last few steps of startup, is to create your session, attach action sets, create your reference and action spaces, and create your swap chain. And then finally, you are ready to participate in the frame loop and handle input. There is an instance-wide event system that you will be polling periodically in order to progress. And we will go into all of these steps in a few minutes. So OpenXR uses a hierarchy of handles. These represent objects that have a defined lifetime. They have create and destroy, and all of them, except for the instance, have a parent handle type. In OpenXR, unlike in Vulkan, destroying a handle destroys all its descendant handles. So if you destroy your session, that will also destroy all spaces and swap chains that were created from it. And if you destroy your instance, that will destroy the session, space, and swap chain, as well as the action sets and actions that are associated. So if you want to be lazy about your cleanup, you are able to. However, there are separate destroy calls for each of these handle types. Language projections might handle these for you. For instance, the C++ header has some RAII handle types that automatically handle destruction when they go out of scope. Next slide. In addition to the handle types, there are two additional sort of special types called atoms. These are opaque, just like the handle types, but unlike handles, they have no defined lifetime. They're associated with an instance, so you don't save them and reuse them, but they do not have a create or destroy function. They have lookup functions. The XR path atom type is frequently used. This is a number that represents a semantic path. So semantic paths are a concept that are used in a variety of places in OpenXR. They are hierarchical paths that are a bit like URLs. And the atom, our path type, is an easier way to pass them around without having to worry about the complications of passing around strings. So you just, when you want to use a semantic path, you will look up the corresponding XR path atom from the instance and cache that. And so then you only have to pass around an integer instead of passing a string. System ID is a unique identifier that identifies a system. A system is a XR environment with a form factor. So that might be a handheld AR magic window device. It might be a head-mounted display. Those are the two basic system form factors that are in the core spec. And so that's only used in a few places. Slide. So now let's walk through what you do in an OpenXR application. Your first step is creating an instance. To create an instance, you first have to specify a number of things that you would like. As I mentioned, you need at least one extension to render anything. If you don't want to render anything, that is, if you just want input in a headless mode, there's actually an extension for that. So you will always have at least one extension and possibly more enabled. So you need a graphics binding extension. If you have optional functionality, so if you have features that are not required for your application, but if they're available on a runtime, you'd like to use them. There is an enumerate call, enumerate instance extension properties, that will tell you what extensions are supported. So you can only pass that you want to enable the extensions that are actually available. If you don't have any optional features, so if all you're passing in is, say, your graphics binding extension, and that's a must-have, you don't need to enumerate the extensions. You can just enable that in your creation of the instance, and if it's unavailable, you'll just get an error, and that'll be fine. Additionally, there is a way to specify which API layers you want. Now, API layers can be loaded implicitly by the loader. They can be loaded explicitly by the loader through an environment variable or other system-specific way of specifying them. But it's also possible for your application to request a layer if there's some functionality that a layer provides that you'd like to use. Layers are able to provide their own extensions, which would be one case you'd want to use that. So if that's something you need, there's a similar enumerate call for those API layers. And just like in Vulkan, there is an application info struct that lets you specify the name and version of your application and the name and version of your engine or shared rendering system with other applications. This provides information to the runtime so that it can identify your app, and if determine there's a performance issue or if there's some app compat things, that can all key off the application info. So once you have all that information figured out and populated in your instance create info, you call XR create instance. And all these things that look like links when you get access to the slide deck later, these are all links to the specification. So once you have an instance, you then need to get a system and views. I alluded before to form factor. At 1.0 release, OpenXR natively supports two basic form factors. These are head-mounted displays and handheld magic window style augmented reality. Can ask for the one that you want because you'll be designed for one of those, and the runtime will respond with one of three options. It'll either say, yes, I have a system like that. Here's the system ID for it. It'll say, no, I cannot have a system like that. This environment isn't compatible. Trying to run a magic window application on a desktop or something like that. Or it may say that the system is temporarily unavailable. This could be that knows that it can do this, but you haven't plugged in the device yet, or alternately in a device that could support multiple modes. So like a slide-in phone holder VR, which is less popular these days. Someone is echoing me. You might need to slide it into the headset in order to get your VR environment, for instance. So that would be a temporarily unavailable return code, in which case you would just retry if you like. Then there are view configurations. By default, in the core spec, these are mono and stereo, but there are additional ones available in extensions, and we expect this to continue. This section might seem like it's a slightly over-designed at the moment, but this is part that is here explicitly for future expansion, that we know there's going to be additional devices, additional form factors, etc., and we want to be able to handle those. So if you support more than one view configuration, you can run in mono and stereo, or you can run in stereo or on like the Vario headset, you could run with quad views. You can use enumerate view configurations. In any case, once you have the view configuration type that you're going to use, call the enumerate view configuration views call. And what this does is it gives you the details about each view that you're going to render. So each eye, or if it's a mono magic window, each just the single view. If it's a quad view, the 2 left eye views and the 2 right eye views. The number of views that come back from this call is fixed because it's based on the view configuration type that's in the specification that you asked for. So this is a well-known number. Mono has 1, stereo has 2, Vario quad views has 4, etc. And you can see in our tree on the right there, we've added the system ID atom to what we're using in this. We can go to the next one in a few moments. So at this time, you are able to set up your actions. Actions are the way that OpenXR handles interaction. If you've used the SteamVR input system, the action-based input there, you'll find this is very similar. It resembles it a lot. If not, don't worry, because that's what we'll dedicate the next few minutes to. An action set is a group of related actions for a context, environment, or so on. So you may have a gameplay action set if we're talking about a game, and you may have a menu action set. And so some actions that make sense in a game, run, teleport, might not make sense in the menu, where you might just need select. Additionally, you can have multiple action sets active at once. So if during your gameplay you can get into a vehicle, and there are slightly different controls that you need to drive a vehicle, you don't need to make a gameplay and vehicle action set. You can have just a vehicle action set, which adds the actions you need on top of the gameplay action set. And an action is a semantic or meaningful bit of interaction. It's a thing you do as opposed to a button you press or a control you manipulate. There are a couple different types of these that are supported in the base standard. These are Boolean. This is like a button. So binary on, off. Float is an analog. So this would typically be things like an analog trigger. Vector 2 is a 2-dimensional float. So this would be things like a touchpad, a thumbstick, where you have 2 axes that are related of floating data. Pose is a tracked object. This is the slightly different type of action because the way you get its information is a little different, but that would be for getting things like left hand and right hand, and specific parts of left hand and right hand for different uses, pointing and holding, as well as haptics. There is support for some limited vibrotactile output haptics, so you can specify some feedback in terms of touch, not force feedback yet. Actions have a name. These would be things like grab object, teleport, and hand pose would be some sample names of actions. And you create these with create action. Their parent type is their action set. So each action is created within an action set. So your gameplay might have grab object, and your menu might have select. Everybody following so far? All right. So now you've said the actions that your user can take, but I'm guessing you probably want to be able to specify how they make those actions, how they use the hardware that you've tested on, and this is where suggested bindings and interaction profiles come in. And this is an important part of the portability goal of OpenXR. So for each controller type you've tested, there is an interaction profile. Interaction profiles are listed in the specification. The core spec includes a number of well-known popular controller types. Additional interaction profiles can be added through extensions. So for each one of those, you'll call XR suggest interaction profile bindings once. And to that call, you will provide action and input binding pairs. You can send as many or as few as you like. You don't have to suggest a binding for every action. So if there's some optional action that can't fit onto a controller, you don't have to suggest a binding for that. Furthermore, you can suggest multiple bindings per action in a call. So you might want to be able to grab or teleport with both your left and right hands. So you can suggest multiple bindings for grab object or teleport. And there's a functionality called sub-action paths that allows you to find out which one of those was used. Don't worry about that for the moment. The thing that you're binding to, so you provide an action and a binding. The binding is an XR path atom, and it represents a path string like user hand right, input, select, click. So there you can see that it would be on the user's right hand. It's input. The name of the input is select. So if there's a select button, and then click is what the user does with it. So when someone clicks the select button, that will trigger whatever you have suggested. And there are a few extensions already that add more interaction profiles. I'll have a little box in the bottom for all parts of the spec that have extensions so far. We can move on. So because this is a somewhat new concept, especially if you haven't used Steam VR Input or the Steam Input API before, I thought we could go through an example. So I went through the Hello XR example application that comes with the OpenXR SDK source and took the action information from there. So if you're looking at the source yourself, it's in the OpenXR program initialize actions method. So in this application, it's a very simple application. There's no menu. You just can look around. There are some cubes locked to different spaces, and there's cubes attached to your hand, which react when you press some buttons on the controller. Very simple. So it's all in one action set called gameplay, because it's a very basic application. All of the actions are specified for both the left and right hand as sub-action paths, because we might want to know which hand did an action. So if you do a grab, you'll check your grab action. It'll say, yes, it's active, and yes, someone is grabbing. You want to be able to find out, okay, which hand are they grabbing with, so that you can make your animation correct, so you can make your interaction correct. And that's where sub-action paths are. So if you look here, we have you have grab object. You also provide at creation time a localized name for the action. This is for providing a UI in the runtime to rebind or change the bindings. Grab object is a float input, and it's specified for both user hand right and user hand left sub-action paths. The hand pose action is a pose input, also for left and right hand. Quit session is a Boolean, also specified for left and right. That one probably could have been specified without sub-action paths, because you don't necessarily need to know which hand chose to quit. And then vibrate hand is a vibration haptic output, also on left and right to match. So let's look at the suggested bindings. As the name suggests, these are only suggestions. The runtime is allowed to vary from these, whether it's because there is no device of this type connected, or if the user has chosen to rebind, whether for personal preference, accessibility reasons, etc. This first example interaction profile is special. Standard defines a KHR simple controller, which does not correspond to any actual hardware. Instead, it serves as a minimal subset. It's a least common denominator that should be easy to map to just about any motion controller. And it only provides a few inputs that you can bind to. So we've provided a binding for all of the actions. Note that the grab object action is a float action, but here we've bound it to select click, which is Boolean. This is okay. The runtime will automatically convert it to a float, just to 0 or 1. The specification has a list of these conversions for common cases. All the rest makes sense. So user hand left, we're connecting to input grip pose for the hand pose. There's a grip and an aim that specify different coordinate systems on a hand. The exit is on menu click, and the vibrate is on the haptic output. Next slide. Okay, so this is for the HTC Vive controller. There's mostly just one difference here, and that's that the grab object action, instead of being bound to select click, there's no button that's commonly known as select on the Vive wand. So here instead, it's suggested for the squeeze click input. Like the simple controller, it's still a Boolean, but it's the squeeze input instead of the select input. Everything else matches the simple controller. So in this call to suggest interaction profile bindings, we pass almost the same. And you can see the interaction profile is actually specified by a path, just like the inputs themselves. Here it's interaction profiles, HTC Vive controller. All right, next slide. It's hard to see if I'm going too fast with all these avatars, so if someone needs me to slow down, let me know. The last example for suggested bindings that we'll look at is for the Oculus Touch controller. And here there's a couple differences. Number one, it has a float input. It has an analog trigger. So it has something that we can connect to the grab action called squeeze value that is actually analog. It's an actual float. So when the application checks grab object, it's not going to just get 0 or 1. It could get any value in that range. So there's no conversion that's being done by the runtime there. Additionally, there's a menu button only on the left controller. So you can see we don't actually specify a binding for quit session on the right controller, and that's okay. Like I mentioned, you don't have to specify a binding for everything. Okay, so now we have all our actions, action sets, interaction profile binding suggested. We have that squared away. Now it's time to finish up our setup. So we'll create now a session. Create a session, you first need to take care of your graphics binding, your graphics API that you're using. You need to do your graphics bindings, get graphics requirements call. All or almost all graphics bindings will have a call like this, and it needs to be done before XR create session. What it will return is things that are important in order to render on and render to the right GPU for your VR or AR device. You'll also need to create a graphics binding struct. What's in this struct varies between different graphics bindings APIs, but each of them have a graphics binding struct. and you'll chain it on via the next pointer of XR session create info. I haven't mentioned the next pointer too much. If you're familiar with Vulkan, you know it has an S type field for specifying the type of a structure with an enum, and it has a P next for chaining on additional structures. Similar to that, OpenXR has a type enum that specifies the type of the structure, and a void pointer called next that allows you to attach additional structures in a chain style. This provides a sort of dynamic typing and extension system. Most of the time when you're doing this structure chaining, it's because of an extension, but not always. There are some parts of the core API that provide structures you chain on via next. So this is the first time you'd absolutely have to do that. You chain on this structure that contains graphics API specific stuff to your create info when you create a session. And when you create a session, you also need that system ID that we got earlier when we looked for the form factor we wanted. Once you've done that, and you now have an XR session, you need to attach your action sets to the session. This informs the runtime that you'd like to use those action sets with this session. You could have multiple sessions over time. This associates them with the session, and importantly, it makes them immutable. So you have to do all your action setup first, all your action sets, all your interaction profile bindings must be done ahead of time. And then when you attach it to your session, those become immutable, and you get an error code if you tried to modify them. If you happen to be working on a game engine where folks are going to be editing their actions, obviously this sounds like an inconvenience. The official way to deal with this is if you need to change your actions, you tear down your session and your actions and your action sets, and then recreate them anew. So this sounds a little bit like a hassle. But there are some important reasons that we have you do the action setup all up front. And this has to do with rebinding. Keep in mind that OpenXR is intended to make applications that can run across different hardware, whether or not it exists at the time that the application is authored. So it's possible, and in fact, it's quite likely that none of the interaction profile bindings that you specify are going to match the available hardware. By attaching at the beginning of the session, that gives an opportunity for the runtime to pop up a rebinding interface. So a way to say, here's what the application is going to have you do. Here are the actions. Here's the controller that you have connected. How would you like to issue those actions from the interaction device that you have? Additionally, in some runtimes, you might have a way to save or share these bindings. So not everyone with new device X has to make a binding for your application. It could just be that the first person with new device X who runs it makes their binding, and then they share it. And then when other folks with that new device X try to use your application, your runtime might say, oh, someone has shared a binding for this. Would you like to use it? If you were able to add action sets and actions at any time during runtime, there might be paths through your application or scenes that use actions that aren't used anywhere else. And so if someone creates a binding at the beginning, the binding might be incomplete because it wouldn't have the actions that you'd add later. This would essentially make multiple places where you'd have to pop up binding UI. It would reduce the value of being able to share bindings. And so it would really impede the hardware independence that we're looking for with OpenXR. Just remember, you have to do all your action setup at the beginning. It's not meant to modify. So come up with those lists, make those actions and action sets, and then at runtime, you can just choose which ones you're actually using at a given time. All right, we can go to the next slide. So there's another handle type that we haven't talked about, and that is a space handle. Space is a coordinate system. It's a frame. There's a lot of different names for these things. We call them spaces here. And there's multiple ways to get these XR space handles. There are some spaces that are called reference spaces. You get these using your session handle and an enum. These are local space, which is essentially like sitting or standing. It's just sort of a local space. Stage space is like a room scale space, a standing space. Those will often have bounds that you can look up. And then view space is essentially head or eye space. So if you need to fix something that's to the view headlocked, like a heads-up display, a HUD, or something like that, you would use view space. Or if you need to like target with the gaze. And so these are all created with XR create reference space. You pass in your session and your enum, and you get out an XR space. Another kind of space is an action space. As we mentioned earlier, you have a type of action called a pose action. And an action space is how you get most of that data. So if you create a pose action for your right hand, you would use create action space with that pose action to get an XR space, and then you can treat it just like any other XR space. So in both of these cases, for both reference and action spaces, as well as any others, these are extended in extensions, and we anticipate there to be more kinds of spaces in the future. Session is the parent handle. So if you destroy your session, that destroys all your spaces. You can also specify an additional fixed transform at handle creation time. So if you want to not track the grip, but you want to track something a little bit past where you're holding, you can include that at creation time, and then all lookups with that XR space handle will provide a slightly transformed location. The way that you get the data for these spaces is with XR locate space. And importantly, you always find the location of one space relative to another. So you can't just look up where your hand is, because if you're sort of considering generalized coordinate systems, there's not necessarily a single unique origin. So you need to say, in what space do you want to know where your hand is? Do you want to know where your hand is relative to the origin of the stage? Know where it is in stage space? Do you want to know where it is in view space, where it is relative to your head? And so you'll provide two spaces to XR locate space. And the last handle type that you'll work with regularly when working on your app is a swap chain. We haven't said anything about actually rendering your app yet. Graphics APIs have different formats for their swap chains and images. So you can use XR enumerate swap chain formats to get the ones that are supported on your runtime for your graphics API. This is used across all the graphics API extensions. It just returns an untyped uint64, and it's up to the graphics API binding extension what that actually means. Then there's a create swap chain call, XR create swap chain. And this creates the swap chain and images behind the scenes. Then, so that you can actually render into those images, those buffers, you get access to them using API-specific handles or references, right? Every graphics API has its own way of referring to buffers, images, swap chains. And for that, you use XR enumerate swap chain images. This is kind of a weird call. It's a little bit different than others because you will know what graphics API extension you're using. The core spec doesn't, but the extension knows as well. So you pass in an array of extension-defined structures. So there's, a Vulkan swap chain image structure type, and it contains what you need to render in Vulkan. So you'd create an array of those structures, and you'd have to cast that pointer to a generic type to pass it in. But because you know what type you're calling, because you know your graphics API, and the runtime knows your graphics API, both sides will cast it correctly. And so you save this information, these buffers, to use every frame. You don't want to call this regularly. You just call it once at setup time. Now you're in the frame loop. Now you're actually running. So here, there are a few functions that control the progression of the frame loop. XR wait frame is a blocking call. So you call this when you're done with as much simulation as you can do that's not dependent on your head pose. You call XR wait frame to block before doing head pose dependent simulation and rendering. This lets the runtime schedule you so that you are doing that work as close to the next frame being displayed as possible without going over. So call XR wait frame, then do your head pose dependent simulation. XR begin frame is what you call before doing GPU work. Here, GPU work means like executing command buffers or submitting command buffers. You can assemble them ahead of time, but don't execute them. Don't do any actual work on the GPU. That depends on a specific frame until XR begin frame is called. And once you're all done, you call XR end frame to submit the image. And the layers, the composited layers. These XR begin and end frame calls must be ordered as if they were single-threaded. You can call them from any thread you want, but you have to treat them as if they were single-threaded. So if you're going to have them on different threads, you need to handle the synchronization yourself. You get out of XR wait frame, you will get a predicted display time and a display interval that will tell you when you expect the next frame to be displayed. You'll need to use that throughout your rendering and when you're getting your view information, and then you pass that back into XR end frame. So if you're doing pipelined or multi-threaded rendering, this can get a little complicated. You can have at most one XR wait frame pending at a time. So just like begin and end, you can only have one of these running. You have to treat it as if it were on a single thread, even though you can call it from whatever thread you want. Additionally, each XR wait frame must eventually be matched with a unique XR begin frame. They come in pairs. If you have a wait, you must have a begin. And if you have a begin, it has to have a wait. So you don't have one without the other. Any XR wait frame must block until the previous frame's begin frame is called. This is more for the runtimes than for the application authors, but should be active. So you'd call that within your gameplay loop, your gameplay simulation loop, and say, please activate gameplay. And if you happen to be in your car, you'd say, please activate gameplay action set as well as vehicle action set, for instance. XR sync actions is the only time that non-pose input data will update. It will stay the same between XR sync action calls. So that's your synchronization point. Pose input, they will continue to update continuously, but only if they're in one of the action sets that's active. So if you're only looking at hand pose during gameplay, then when you're in the menu action set, you wouldn't be able to locate the hands in the menu action set. After you've done sync actions, you'll get the data. If you try to look up an action that belongs to an action set that wasn't specified, you'll receive an indication in the return structure that that action is not active. And that's fine to do. You can look up non-active actions. It just will tell you it's not active. Additionally, actions might not be active for other reasons. They might not get data if, for instance, your session is not focused, if the user switched to a different application, or for privacy or for security reasons. So if there's an on-screen keyboard that popped up and the user is typing their credit card number in to do a purchase, you're not going to get action updates from that you'd be able to extrapolate their credit card number from, that sort of thing. To get most action information, you'll use an XR get action state call. There is one of these for each type of action. There is one for poses, but the bulk of your pose data you'll get through XR locate space. You just get sort of the metadata through get action state pose. Okay. So now we can set up, we can do our frame loop, we can render, we can get our input. We also do have to keep track of events. There's an XR poll events call. It requires an instance. So it's an instance-wide event queue, but most events only happen during a session. So they'll include one or more handles to tell you what they're talking about, because you might have more than one session over time. Events are fairly varied in what they describe. They might describe changes to the active interaction profile. This is where their runtime would say, okay, you've said you have bindings for a Vive controller and an Oculus Touch controller, and I'm going to use the bindings for the Vive controller. Now, note that the runtime in specific with the interaction profile stuff is not required to actually tell you the actual device it has. So if some future device X is being used, not going to tell you I'm using interaction profile for future device X. It's going to tell you a close match or something. It's not going to surprise your application with something you haven't tested with. But just because you're getting that information back doesn't necessarily mean that's exactly the hardware you're using. So you can get the active interaction profile through an event. Additionally, you'll get events regarding continuity of reference spaces or tracking. This is especially important for systems that use camera-based or SLAM tracking or a larger sort of world scale tracking. And you also, importantly, will get changes to session state. So you have to poll events. If you don't poll events, your application will eventually stop working. Poll them fairly regularly. It's reasonable to do this before you sync your actions. That's a reasonable enough time and frequency to do it. The way that you get your actions is you provide an XR event data buffer. This is essentially just a big structure that just has type and next, and then a big long series of bytes that are just sort of untyped. So you pass in the structure, and when you return it, the runtime, so you say that the type is XR type event data buffer, but when you get it back, the type field will say something different. And so then you reinterpret that structure as the something different type that it is. This is where that dynamic typing gets used fairly heavily. And So then once you've cast it, once you've reinterpreted that structure as the actual event that it is, you can handle it. And you'll typically want to drain the event queue every time you go through. So you won't just call poll events once, you'll call poll events until it says there are no more events available. And that will keep you from falling behind. Okay. So we've covered a lot of ground. We've talked a little bit about myself and about OpenXR, how it fits in the world of APIs and the working group. We've gone through the application structure in great detail and the action system as well. And we'll have a little time for question and answers. On this slide, I've also put a number of links. I tried to keep the URLs short, but these will be easier if you can get the slides later. The organizers have them already, and you'll be able to click those, get access to some additional information. If you're watching this at a later date, or if there is a question I don't get time to answer, do please feel free to come to one of the community sites associated with OpenXR. We have a Slack chat that I'm pretty active in. We have a forum that's less active than the chat, but it's still there. We have our open source projects, and bring your questions there, because we'll want to be able to answer them, and you'll have access to a large group of folks who know a lot about this. If you're interested in an open source runtime for OpenXR for Linux or other systems, Monado is there. That's a community project founded by my team, by our team at COLLABORA. It's not an official KHRONOS or OpenXR working group project, but there's the runtime has its repositories on freedesktop.org, and there's also some additional software there, including some sample applications and things that are not necessarily dependent on Monado. So even if you're not using Linux, it's worth a look in that freedesktop.org GitLab organization, and poke around and see what you find. Thanks for your time. So I think the next slide is just sort of the title slide again. So I'll take questions. I'm assuming I didn't explain it that well, so there's a few things I had to skim over. Who's
Thanks, you, Ryan.
I see a light bulb over here. Does that mean you have a question, or does it mean we're playing with the emotes and we're trying to figure out what they do? All right. If there's no questions, then I guess I'll wrap up. I'll stick around in the environment for a little while longer. If I miss you, please do stop by the KHRONOS Slack chat, and I'll greet you there as well. Thanks for your time, everyone.
There's actually a written question.
Oh, there's a written question.
Chat. Yep.
Oh, okay. I can't see that. I'm doing this through an HMD right now, so I can't see the written questions.
I'll read it for you. Is there any abstraction and easy-to-use framework that uses OpenXR?
So there's runtimes. So if you use Unreal Engine, that has OpenXR support for several releases now, and so that's one way to do that, and that will take care of most of this work for you. If you're using C++, the OpenXR HPP project provides a header wrapper that handles most of the nitty-gritty details of this for you, that handles it, sort of the mechanical parts of the API, the destruction of objects at the end, the typing stuff, that sort of thing, and makes it easier, but it doesn't really provide a framework. It's intended to make it easy to integrate into existing frameworks without too much modification, but I'm not aware of any generic framework that's not a game engine at this point. Does A-Frame use it? I see. So as of Chrome 81, I believe, on Windows, Chromium 81, so Chrome and Microsoft Edge Chromium now use OpenXR as their preferred WebXR backend. I haven't checked in with A-Frame to see if it's using WebXR yet, or if it's still using WebVR, the earlier prototype standard, but it's can be used behind an implementation of WebXR, and we do have a liaison agreement with WebXR. So, and there are folks on both committees, so that we're kind of interacting there. There's no direct usage by A-Frame. Did I miss a question? Saw a question in French in the chat that I cannot read. Sorry.
Yeah, no, it was not related actually.
Oh, okay. Thank you.
Yeah, I'm gonna ask as well if that's okay. I'm currently using Unity. I was quite aware of the OpenXR integration in the past versions, but I'm currently using 2019.3 and I don't directly see the OpenXR integration. Do you know anything about this?
So, as far as I'm aware, and I don't use Unity that regularly, Unity has not had support for OpenXR yet. They've referred to their XR framework, but it's just sort of using XR in the generic sense of AR and VR. It's not specifically an OpenXR using implementation. Now, that said, they are a part of the working group and they have participated in discussions, but I don't know what their plan is for timelines for implementation on top of OpenXR.
Okay, thank you.
Right. What do I think of the future of OpenXR? I see in the chat here. I'm very excited for it. It's very, I mean, I'm biased, I'm the specification editor, but I've been involved with the group for a long time because I really believe in it. I'm really excited for it. We're getting to the point where there are more and more runtimes available. It's ready to use. The conformance tests are nearing completion. And we're seeing a steady stream of extensions coming out from vendors. So we're up to 1.0.8, I believe, as of this time, and most of those patch releases have included additional extensions from vendors. So it's really great to see. I'm very excited for it. I'm real excited to see folks starting to use it on the application side. Looking forward to seeing more runtimes coming out, and looking to see what we do next to add more functionality through extensions to handle new devices. I know Microsoft, if you click on that link to their OpenXR page, they actually have published a roadmap on the extensions they'll be doing. I don't know if any other vendors have done a similar thing, but we're working on a lot of great stuff, and I'm very excited to have folks use this in the world. Thanks again. Like I said, I'll stick around a little bit until the next talk starts here, and then I'll be in the chat. I can't figure out how to run this without my HMD at the moment, so I'll be in the Slack chat later today. Thanks, everyone.